Okay, this lesson 1.5 is on difference quotient. Which I abbreviate as DQ, which always reminds me of Dairy Queen. Okay. Alright, let's start with a picture. And I'm just going to draw the axes, and I'm going to just draw some function which looks like a parabola, might be a power function, but just some curve there. Okay. So recall that when we found the average rate of change between 2 points, we would try and draw a straight line between those 2 points. Pretend this is a straight line between the 2 points. Okay, so we drew a straight line between the 2 points, and then we said that this was some x-coordinate. I'll call it x sub 1. And this is another x-coordinate. I'll call it x sub 2. And in the example we did for average rate of change, this was 1 and this was 4. But I've just now labeled them x sub 1 and x sub 2. Well, the x sub 1 has some y-coordinate over here. We'll call it y sub 1. And this second point also has some y-coordinate. I will call it y sub 2. And so you calculated the average rate of change. You said that was y sub 2 minus y sub 1 all over x sub 2 minus x sub 1. Okay, so let's take that a step further. Let's get rid of these y's and let's use our function notation. So I'll pick a different color for that. So when I put x sub 1 in, what comes out in function notation looks like that. The function of x sub 1. When I put x sub 2 in, whatever value that is, what comes out is the function of x sub 2. So now we're just going to rewrite the average rate of change and get rid of these y's. So y sub 2 we're just now going to call f of x sub 2, and y sub 1 we're now calling that f of x sub 1 all over x sub 2 minus x sub 1. Okay? So that's just kind of updating the difference quotient with function notation, or updating the average rate of change with difference quotient. Okay, so now what we want to do is we want to say, well, maybe I don't have a specific first point and a specific second point. So what I want to do is I want to say this distance here between these 2 points I'm going to call h. So there's some distance between the first point and the second point. If this was 1 and if this was 4, the distance between here would be 3, because 4 minus 1 is 3, so h would be 3. But anyway, h represents the distance between x sub 1 and x sub 2. So I want to then rewrite this. I'm going to pick a different color for that also. I want to rewrite this. I want to get rid of this x sub 2. And I want to instead call this point x sub 1 plus h. Because if I'm here at the origin, of course the distance here is x sub 1, and then the distance here is h, so this total distance is x sub 1 plus h. And Now you can see that I don't have the second h sub 2. I just have a, I don't have a second x sub 2. I just have an x sub 1 and an x sub 1. So what I can really also do is get rid of these little subscripts here. Okay. So x is the first point. H is the distance between the first and the second point. And now the second point I'm calling x plus h. So let's look at our y values over here. Well, if I put in x, out comes y, but we're not calling it y, we're calling it f of x. So that's nothing changed there, that's still the same. But now look what happens with the second point. X plus h is my input. So instead of f of x sub 2, this is now f of x plus h. This means x plus h went into the function. So the difference quotient is kind of like the average rate of change, except we're going to be using this h. So second point minus the first point. Y sub 2, except look, my y sub 2 now is f of x plus h. I'm going to subtract y sub 1. And my y sub 1 is f of x. I'm going to divide that by x sub 2, but I'm really calling my x sub 2 x plus h. And I'm going to subtract x sub 1, which is really just x. I can simplify this a little bit here. Stays the same, but the denominator, I have x plus h minus x, so x minus x, those are gone, and I'm just left with h. And this is the difference quotient. So that's what the difference quotient represents. It represents the slope, or the average rate of change, between these 2 points right here, but instead of giving it an interval like 1 and 4, or x sub 1 and x sub 2, now we said the distance between the two x points is h. So that's why when you're done with your difference quotient, you have f of x plus h, that was your old y sub 2, minus f of x, that was your old y sub 1, and divided by x sub 2 minus x sub 1, which simplifies as h. That's the difference.